presenters are Monica Colbert. Monica Colbert is currently her 9th year as a middle school math teacher and a 3rd year as a math content coach in Montgomery County, Maryland. She has been a member of the instructional staff for Nevada Math and Technology Camp for more than 7 years. She has been, Monica earned a dual Bachelor's of Science degree in Mathematics and Secondary Education from Syracuse University and a Master's in Education degree in STEM Teacher Leadership from University of Maryland. Monica served as a AmeriCorps member with City Year Incorporated, where she provided math and English academic intervention in Washington, D.C. She is passionate about giving learners a fun and successful experience with math, especially algebra. And our other presenter is Dr. Michael Liu. Dr. Liu has worked over 27 years in education technology field in various roles. Michael Liu started his dissertation research work in 1988, applying artificial intelligence to design self-learning controllers for engineering process. This led naturally to his interest in human cognition. Since 1995, he has focused on developing K-12 mathematics supplemental material using education technology. His strength lies in the ability to coordinate between educators and programmers, turning the best practices into digital resources that can be shared by millions. One of Dr. Liu's passion is to reveal the inner workings of math and algebra and figure out the right way to engage students, which ultimately boosts their achievement. By helping students one by one, he believes we can transform math or algebra from STEM keeper to gateway. Ladies and gentlemen, please welcome Dr. Liu and Monica Colbert.
Thank you so much.
Take it away, guys.
All righty, I am going to share my screen. Okay, are you all seeing? Can you tell me what it is that you might be seeing?
Just a black screen right now.
Okay. Let's see here. Where might my controls be? Okay, are you seeing the screen?
Yeah. No, yes.
Okay, yes?
Yes.
Okay, wonderful. All righty, so we are here to share with you about Algebra Zero, and as you heard from Mike, and thank you so much for the warm introduction, we are going to focus on the missing step in math and algebra success. I am Monica Colbert, and I'm so happy to be here with you all. So who this session is for, and hopefully who can benefit from this, really educators of grades 3 through 11, and especially administrators. And we all are in the right room, right session, so thank you again. So the main goal of Algebra Zero is to double student achievement in math with half of the time. And with that, we hope to have students relearn once to retain forever. Oftentimes, I know having students retain the math understanding is something that I feel has been my greatest struggle, because I still always find myself having to revisit concepts, revisit skills. So through Algebra Zero, which we're excited to share with you, you'll hopefully see some new ways in which we can mitigate that. So the top 3 challenges for teaching and learning, which was shared and highlighted in this report, that honestly is so relevant in today's classrooms and something at which we can see, regardless of where we are in the nation, is that there's a lack of motivation amongst learners. And this gives teachers oftentimes a greater challenge, a greater workload, just to try to reignite student interest in learning math. And we are finding, the reports have shown, that students are usually coming to the on-grade level math courses unprepared. And with this unpreparedness, there are several gaps that teachers are having to fill in. And while that's expected, because students are in various places and they are entering just with different skill sets that they bring to the classroom, the unpreparedness usually is why teachers are struggling with getting all students to achieve the common goal, whether it is algebra or whether it's a lower math. Unpreparedness is the greatest challenge. And that relates to how there is such a wide array of learner needs. Oftentimes, teachers can't pinpoint the way to get to every student, and it's time consuming just for us to reach each and every student to fit their exact needs and exact learner styles. So with these three challenges, we're hoping that something different can support learners, can support teaching as well. So the traditional teaching method, which I can attest to, which I gained from my methods courses in undergrad and just throughout my years of experience, typically we deliver the conceptual information by showing students the procedural way of addressing problems. And oftentimes it is the concepts are secondary, but the procedure is typically leading the instruction. And so the emphasis oftentimes is placed on the process and practice. And usually students are just trying to memorize, what are the next steps? How do I do this? And trying to recall exactly what they saw the teacher model. And from there, pretty much repeating what has been modeled to them, and that mainly being a process. So where we think there could be some innovative way of teaching learners, especially specifically for algebra, we find that it's most important to do what will allow for a teachable moment. And what can generate a teachable moment just really means like allowing students to be a part of that teachable moment and not just have teaching being something that is brought to them. We also find that it's so important to focus on conceptual understanding. And while I had just mentioned the concept is usually paired with the procedures, conceptual understanding is how learners are guaranteed to really retain the information, really retain the content, and through that further apply it, as opposed to just the process of how to do something step by step. So with that, it will automatically promote computational fluency if students understand the process, understand the concept and then apply that. And of course, practice has to be a part of anything that we do. So computational fluency is guaranteed to come after we've engaged them, after they've mastered the conceptual understanding, and then can practice their way through. So one way in which we think that this is going to change, I'd say, the teaching game, so to speak, is through narrative-based approaches. So narrative-based approach is literally a narrative around math. And by that, we're really meaning fictional stories, not word problems like we usually think of when students are pairing literature and mathematics, but actual stories and a story-based approach in order for students to read a story or hear a story, maybe even watch the story. And through that, they're learning conceptual understandings that they then are applying. So the storyline that Algebra Zero has developed, and all of which I'm hoping you all will one day explore and use in the classrooms and in your schools, it reaches from grades K all the way through. And each grade band, the stories cover in its chapter stories. So it's like a series, and it covers every math concept, every math standard, depending on which grade band you focus in on. I'm a middle school math teacher, so what I've loved best has been the middle school story, and that one is best for the algebra students, beginner algebra students. And while I say beginner, it could also be for students who are reviewing algebra and just trying to make sure that they build their algebraic thinking and can have the conceptual strength in order to use that moving forward. So focusing in on that, here's actually one of the 3 series that's been developed so far with Algebra Zero. And this goes into variables, it touches on integer operations, algebraic expressions, linear equations, and so on. So you can just kind of take a look at it. And this is just one example of how we've engaged students in conceptual understanding and having them watch stories and watch videos that make math conversational, but also have them understand what really is this math and what does it really mean and how can I best understand it. This has been quite an amazing experience when I had the opportunity to use this in Nevada as I was at University of Nevada, Reno with a group of students for a summer program, and it hooked them. We have come into an age where binge watching is so common and students love a story. They love something that can get them to say, well, what happens next? And this narrative approach to teaching algebra specifically, it really allows them to just enjoy the learning, and it doesn't necessarily feel like someone is just directly teaching them through direct instruction and showing them processes and procedures. So this has been something that I can say has completely enhanced my teaching experience, especially in the sake of integer operations, which you're going to hear Mike speak on. And that's something that I can say that's an area that I saw the greatest improvement. So specifically thinking about operations and integer operations to be exact, there's usually this emphasis on the different ways in which we can add integers together. And so as we consider, just say 2 plus 3, there's different ways if we include integers, there's different ways that we can say what exactly we are adding together. So we can add positive and negative, negative and negative, positive and positive. So with this integer operations, typically students are learning this by way of rules, and those rules oftentimes have to be memorized. So if I am teaching students and they're adding a positive and a negative, and they're having to think about which one is greater or which one is less, and then considering a number line, usually it does involve some kind of rule memorization. And while that serves some students, I can't say that it's for everybody. And I'm sure if you are one that has experience teaching integer operations, you probably have experience where students oftentimes can't hold on to which rule to use and where and when. So there's been a shift in that as I've used this story-based approach in order for students to see it a different way. And so the subset of learners that this fits, it works for them, and they can catch the rules and they can apply the rules, and that's fine. And it's for some, but it just has not been for everybody. So as we consider integer operations and specifically the addition of integers, there's so many different ways that we can go about adding two values together, two quantities, and having this be shown just with the values or with the, I've used like a positive and negative symbol before and just had students see what might pair up or cancel out. There's so many ways that we can do it. And it's oftentimes just the hope that we're going to gain understanding, and the students are going to gain understanding by ongoing practice. And this ongoing practice, I can't say it always allows the concept to sink in about exactly what is it that we're sharing with them and how is it that they can actually retain the conceptual understanding. So if I could say a connection with the Albert Einstein, what we know insanity is doing the same thing over and over again and expecting different results. Well, not to throw any shame, because I'm still a middle school math teacher. So I'm in a classroom and I have some things about my practices that relates to what I just touched on. But honestly, doing the same practice over and over again and expecting math success, that in a way has caused a bit of insanity or disconnect between the classroom practices and student outcomes. So if there is a way to show students the conceptual understandings in order for them to learn it or relearn it right away one time, and then really retain it, hold on to that and apply it, we'll see so much more success with students. So I'm going to allow Mike to hop in, and Mike will share with us some ways in which Algebra Zero has arrived at giving students stronger conceptual understandings right away.
All right. Thank you, Monica.
Yeah, do you want me to keep this up or would you rather share?
Well, can I share my screen or?
Of course.
Let me know when you see my screen.
Okay. Have you started sharing?
I thought I did. Well, give me 1 second. Let me share it again.
And I'll stop my share.
Can you see mine now?
Yes, we can.
All right. Give me 1 second. Now, let me review a little bit, what Monica said, I know a lot of those content are pretty boring to kids. I don't blame them. Let's say out of 100%, maybe 20% of the kids are, like mathematics, and we can't deny the fact the majority somehow, just something they have to finish, and they're not really crazy about it. And just an integer operation, the for operation alone, for addition, we have 4 different rules. Okay, then subtraction, we introduce 1 rule. We say, wow, great, there's only 1. But however, if you really look at it, what the rule says is that subtracting a number is the same as adding is the opposite. Even though it's a 1 rule, but to a lot of kids, that's at least 2 rules. Why? Because we're talking about either subtracting a positive number or subtracting a negative number. Anyway, so just gave you one specific example. A little like a simple, subtraction problem, what we deal with, in grade 1, grade 2, like a 5 minus 2. Now it becomes 5 plus negative 2. He says, that's crazy. What are you guys doing? Why we're doing this thing now? I don't even know how to subtract anymore. Before it's 5 subtracted 2 equals 3. Everybody knows that. But now, based on the rule, we hardly explain why we're doing what we're doing. Again, back to the multiplication. There's another 4 rules. Basically, it's the same sign versus the opposite sign. Some people say, hey, the 4 rule, we can cut it down and, change that into 2 rules to make it, kind of like a little easier to memorize. But there's still 4 rules because the same sign. What do you mean by that? And eventually, we have to explain to the kids, positive, positive, that's the same sign. Negative, negative, that's the same sign. Then, all of those things. But anyway, I'm not trying to make you memorize all the rules. The goal over here to help you see how much actually we want the kids to memorize it. It is crazy. And, barely 10 years ago, I was a programmer. Programming really, the course is really for college. Now we push down to high school. I'm not saying we shouldn't be doing that. I'm not saying that, there's a place for all of those courses. But what I'm trying to say is that we want kids to learn more and more. And now with the pandemic, the unfinished learning, there's just so much we need to catch up. So the traditional way need to be improved a little bit. Again, I'm not trying to say traditional way is bad. No, actually, traditional way is a very, very efficient when it works. That means, for the 20% of the kids, I just pick a number, 20%, it could be 40%, could be 50%, but for the 20% of the kids who just get it, traditional way is the best way. You tell them what to do, they can produce the correct answer. What's wrong with that? Nothing wrong with that. Well, we can discuss more, but we don't have time today. But anyway, for those kids, traditional way is the best. But what about the remaining 80%? They just can't memorize all those rules anymore. Up to a point, some kids, they were pretty good at elementary school level, moving to, middle school. And some have a problem, some don't. Then some are moving to high school, they start having a problem. But anyway, when we use the traditional way, and at certain point, and kids just overwhelmed by all of those things, they had to memorize it. So now the question is there a better way? Is there a better way to do it? So let me go back to the same problem, Monica used earlier. So this part I will call surface manipulation. And the bottom part, I don't have anything right now, is called inner working. To explain what I mean by surface manipulation and inner working, I'm going to use one specific example, like the light switch. Everybody knows the light switch. Everyone knows how to use it. So if you really look at it, this part, I will call it surface manipulation. Switch on, off, that's it. The internal thing, normally we don't really show, that's the inner working. For simple tasks like this, just switch the lights on and off, you don't need to explain a lot of inner working. I mean, it's getting in the way. This is one thing we need to do, just turn it on, turn it off. So you just learn the surface manipulation, that should be it. However, when you deal with mathematics, when one thing is built upon another, there's hundreds and thousands of procedures and concepts, we need to understand. Without inner working for even the most fundamental one, it won't last. So some, just after a while, everybody feel overwhelmed. Now let's go back to this addition problem. So what's the inner working? Well, what I show over here is a traditional tally mark. That's a 1, that's a 2, that's a 3, 4, 5, tally mark. Very few people have a problem with the tally mark. But the problem over here is that when we deal with integer is there's no way to represent the positive and negative. Okay, there's no way to represent that. So what do? What we do is we modify it, improve the traditional tally mark. How do we do that? Well, that was a 2D. Now I introduce a raised tally mark to represent positive 2. Then I introduce a recessed tally mark to represent negative. So what's addition? Addition means, you put all of them together. So think about it. You have 2 bars. You have 3 slots. When you put them together, they're supposed to be exactly the same size, just because, one over here and one over there represent the same size, the absolute value. But that's another thing, we can discuss in the near future. But anyway, when you put them together, what do you see? What's going to happen? 2 bars going to fill the 2 slots. So you have 1 slot left. So what's 1 slot? That's a -1. So if you just have a couple examples to cover, like +5 plus, -3, or +1 or -1 plus, pretty soon, just a 4 or 5 example down the road, the kids can see the pattern. Okay, so let me switch over to the demo side and show you a little bit. Can you see my new screen now? All right. Now, computer automatically generate the problem. And here's the inner working. You can also call it explanation. So basically, that's a +5. That's a -1. What's going to happen when you put them together? Well, you cancel 1 pair. So you have a what? 4 bars left, 4 raised tally mark left. So that's a positive 4. So what about this one? Well, what do you think that's going to happen? So you just actually watch it a couple more times, and most of the kids actually get it. And remember, we said there's 4 rules for integer addition. And now they don't even need the 4 rule anymore, at least for addition up to this point. And this is kind of like a demonstration. Then we have a kind of like a practice. Basically, the kids can just drag and drop. You know, the funny thing is once kids understand the inner working, one kid even says, you know, positive 1. Yeah, that's what you guys want me to do. But you know what? Can I do this? I have 2 bars and 1 slot. They're supposed to be positive 1. Well, we acknowledge, you know, says that, yeah, you're correct. That's why we modify the program to make it work. Kids can see, yeah, that's a positive 1. So here, positive 2, you do that. So that's kind of like a digital hands-on or digital manipulated. And now, you know, once you see that, so yeah, well, by default, you know, you can use a positive 1 or a positive 3 or just, 3 by default. Anyway, we don't have time, so that's why I'm not going to show the rest. Basically, the entire content, entire, you know, thing are free for the whole state of Nevada. So I'm going to go back to, let me see. Now, instead of memorizing 4 rules for addition, like I say, you know, when you have an integer, I mean, positive, the kids can see, well, when I have a, you know, two bars and 3 bars, of course, you know, that's how I'm going to act. Or when I have a, you know, a raise, you know, turning mark or recess, this is what's going to happen. When I have a recess or the slots, and you see, just simply based on that modeling, kids can form a mental image. So they can come up with the rule on their own. So basically, all of those rules we're trying to teach should be learner's own conclusion. It should be something, you know, they arrive at after they understand the content and concept. They shouldn't be the material we use to teach them. So all of those textbook material, I mean, the majority, if we do it this way, they don't need to memorize, you know, they will automatically, let's put it that way. They do need to memorize it, but they will automatically memorize those things. It's a better way. But like I say, you know, I'm not saying, you know, we shouldn't, you know, use the traditional way. Like I say, you know, for a percentage of the student, you know, kids, that's the best way to teach them. But for the remaining kids who just cannot do it with the traditional way, this is another way. Again, I'm not saying this is the best way, this is the only way. This is just one additional way we find, you know, very effective to teach, you know, those students. All right. So should I give it back to you, Monica?
You can keep it going. Yep, thank you. All righty, so thank you so much, Mike. That was well explained and said. So truly, as we have seen, and I appreciate someone noting that that was similar to the 0 pairs, just a different way of showing it. And there's actually interactives within the site where you can see the 0 pairs shown for the concept to really be understood and owned by the students. So through Algebra Zero, we have found the outcomes to be, and we're really confident those that are looking forward to using it in the near future, we are certain that you'll have an improvement of student engagement. The interactives plus the stories, it just gives students a new way to see the math and to understand the math. And through that, it reshapes their attitudes about math learning and builds their confidence. And I can honestly say that this is something that doesn't just relate to the students. There are several teachers, and I'm a math content coach. So oftentimes someone can love math, they can be amazing at teaching it, but there are sometimes areas where the concept is not fully understood by the teacher, although they can teach it very well, and although they can deliver the instruction to allow students to understand it and go through the process of whatever it is that that math topic calls for. But typically with a teacher learning the conceptual understanding in a new way than it was originally taught to them, it even builds their confidence. And it can ultimately reshape the tone of the class for students to be engaged in something that is exciting. And they can then adopt the conversation that they hear in the stories that allows them to lead through their own understanding, where they're able to, like Mike said, develop the rules themselves and not just have it shared with them, memorized, and then applied. So these three areas I have personally seen the proof of this outcome as I was going through Algebra Zero with some of the students in Nevada, and the interactive specifically allowed for my students here in Maryland to really grasp it quickly. And it took a lot of the load off of me because I did less front loading and more just discovery based. We can go to the next one. So it's truly guaranteed to double the achievement with half of the time. So as I mentioned, just having them discover what it is that these concepts entail, it gives them an automatic way to own what it is that they're learning. And with that, a lot less time is spent trying to get students to memorize something or trying to get students to show that they have it by giving them different types of problems where the rule application might fall short for some. So relearning, and it could be a first time learning, but relearning one time through the proper way of showing the conceptual understanding, it does produce retention forever. So as we consider this approach, if you can go to the next one, it's going to support teachers' well-being by allowing teachers to work smarter and not harder. I can say it's a lot of the load placed on teachers' hands when they are the ones just trying to share their understanding with students, as opposed to students gaining that understanding on their own through what is facilitated by the teachers. So if the students have an opportunity to see something, hear it talked about, see the interactives, and have the interactives either being demonstrated with them or they can actually be hands-on with it, we see a lot of opportunity for students to perform better, to feel better about the math that they're learning, and to enjoy it. In order for them to be confident, in order for them to have a different attitude, and for teachers to feel like it is less teacher-led and more student-centered and student-led through the discovery of the concepts that they gain from the stories and the interactives. So Algebra Zero, as Mike had stated in the chat, it's readily available, well, gradually going to be fully released, but there are parts of it that are actually available to you all even today. And there are approved PD credits through Nevada's Department of Education. So you all can have a way in which you can get PD and get credit for it by learning ways of using Algebra Zero, learning ways to apply it in the schools, or have your cohorts, your teaching cohorts, consider it in ways that the students can just have this, I don't want to say more so an intervention, but it's a very strong supplement to any curriculum. It's not going to replace anything, but it absolutely is guaranteed to give students a new way of seeing the math and exploring the math. So you can contact Algebra Zero through this email, and you should absolutely stay tuned to what's ahead, as the entire state will have access to this. And it's such an innovative way of exploring math and just enjoying it. I know I enjoy watching a good story, and I guarantee you and your students will also. So I think we could show you all a little bit of the stories, if you're okay with that. And I'm excited that some of you were eager to have a look before we even finished up. So if you all are okay with it, Mike, are we able to share any of the story for them to see the algebra?
Sure.
Clip?
Yeah. And, in the real story, we do have a rigorous content. Like I say, for algebra part, it goes from a variable, algebraic expression, linear equation, function, it touch every one of them, and actually covers that, in a pretty, a deep, step. But the thing is, for today, we really don't have a time. So what I can do is just show you the story part. Let me see. Should we play from the first one, just a couple minutes? And
If that's okay, I believe that'll give them.
Amelie's Algebra Journey, Episode 1, The Incomplete Message. Topic covered, Overview of Algebra. The first episode not only introduces the characters and setting of the series, but also explains why algebra is needed at all in everyday life. Our story begins in the Pordacre Kingdom, where Amelie, our protagonist, lives alone with her father, Mr. Wells, a bookkeeper and auditor to the king. She often meets with her father on his way home from work, which gives them time to talk about each other's days. This time, however, Mr. Wells bears unpleasant news. He has to leave the very next morning to travel to the neighboring kingdom of Sal for an emergency audit of their trade office. Seeing her concern about this troublesome trip, Mr. Wells tries to change the topic by asking Amelie about her schoolwork. Relieved at this diversion, she expresses her frustration with translating word problems into equations. Her father tries to help by comparing the process of solving a word problem to extracting salt from the earth, since salt production is a significant part of the local economy. In the same way that the extraction process rids salt of impurities, algebra helps eliminate unwanted verbal descriptions in word problems. This demonstrates one small aspect of what algebra can do. Mr. Wells then compares algebraic processes to patterns in the English language to translate daunting, unfamiliar concepts into familiar terms both Amelie and most student readers can process with ease, thus building confidence. The story ends on a cliffhanger. Amelie's father goes missing while away in the Saul Kingdom, and Amelie receives a message with only a few legible words that suggest that something bad has happened to Mr. Wells.
Monica, is the sound okay, or?
Yes, it's been great.
Oh, okay, great. So the first episode actually is kind of like an introduction to the whole story, and basically for algebra, it's kind of like explain a little bit, why we need algebra. It's kind of like why we need this language, why other languages are not good enough in certain cases. So that's a basically introduction. So next episode is all about, variable. Again, in a traditional way, when we teach variable, normally we just tell the kids, hey, variable is a letter or a symbol we use to substitute, a number in our calculation. And again, that's a conclusion. That's a conclusion students should arrive at after they understand it. So when we just simply feed that conclusion to them, it's not long lasting. And they have no idea. Some of the kids even say, I thought, letter belong in English, we should use a number in math. I don't understand. I even have a hard time to calculate the regular number. So now you give me a letter. How do I calculate with a letter? They really have no background to understand why we have to use a letter or a special symbol to in our computation. So the second actually episode, goes through the story, and by building the right concrete context, kids can see, students can see, wow, this is why we need the variable. Again, in the brief introduction, you don't really see that part, but in the real story that's 15 minutes long, and once they watch that, they understand exactly why we had to use a variable or why we have to introduce this new
Episode number
concept.
2, The Magic Crystal Ball. Topic covered, Variables. Amelie has been staying with her aunt while her father is away and is troubled at night by a disturbing dream. In the dream, a mysterious woman appears and says she can help Amelie with her quest to find her father. However, the woman needs to test Amelie to be sure she is mentally ready for the challenges ahead. Otherwise, knowing the truth will put Amelie in great danger. The test consists of what appears to be a magic process whereby the mysterious woman can read Amelie's mind. To avoid the ambiguity and complexity frequently associated with describing creatures or objects with words, the woman proposes that they use numbers. Once Amelie picks a random whole number, the old woman's crystal ball can predict which number Amelie is thinking of. It is puzzling at first, but based on a few clues provided, Amelie realizes that using variables can help reveal how the magic actually works. When she wakes up the next morning, Amelie realizes she must see the king herself. She vows to go to the royal ball where the king has promised to greet everyone there. But no one can attend without an invitation, and it won't be easy to get one.
Okay, today we use a specific example, integer operation to show you actually there's a way to speed up the learning. Actually, there's a way. And it is a very, very likely, if we present it right, and kids can compare, think about it, before some kids, they take Algebra 1, then, they fail it. And then next year they have to take it, it's not uncommon even for some of the kids to take it 3 times. So compare with that. And that, what we're saying is, we can double the achievement with half the time. We're not saying actually, instead of a year-long course in Algebra 1, we can really cut it down to a half year, even though for that 20% of the kids, I do believe it's very, very possible. But for other kids who had to take it, twice or 3 times, so if we can just teach it once like this and be done with it, and that's what we're saying, that's how we double the achievement, with half of the time. So,
Mike, is it okay for us to answer some of the questions in the chat?
Oh, sure. Sorry, I didn't
Okay.
have a time to look at the chat. Sure.
It's okay. So if you wouldn't mind maybe just putting up the last slide, and then I can get started with addressing some of the questions in the chat. And thank you all so much for asking such good questions. So the first thing I see is, when will we get full access? So the access should be fully rolled out by mid-2023. Is that accurate to say,
No,
Mike?
actually, that's the part I can talk about it.
Okay.
And even though it's a free, to be honest, it's so hard to get the words out there. It takes so much time, even so much, effort to really make everybody aware. So it's available now. And basically it's available now. It's really a matter of, so email us, info@algebrazero.com. We can give you the access. I happen to see, another message says, I think this is something probably everybody, cares. How would you recommend, we use Algebra Zero? It's a very, very hard to change your curriculum. We're not trying to change your curriculum. And the thing is, you can keep your curriculum. Nothing wrong with that, except the introduction part. Every teacher actually is struggling on a daily basis, try to engage the kids. They have a solid material. I'm not trying to say the traditional material are bad. Okay, no. It's lacking certain things. One of the component is lacking is the engagement piece, and to a degree, is a conceptual understanding. So let's say, based on your pacing guide, based on your curriculum now, next week, I'm going to teach a variable. So you use Algebra Zero as an introduction. Show, the kids 15 minutes, that story, then discuss it. They build a, kind of like a background, why we need to introduce this a new concept. Then you can just keep using your existing material. Nothing wrong with that. Use the experiment until you get into algebraic expression. So then, you use Algebra Zero to introduce that part. That might be another week or 2 weeks long, course, but just use this thing for 15 minutes, discuss it for 15 minutes and half an hour, be done with it. That's it. Then, you know, by the time you need to introduce linear algebra, linear equation, again, use the Algebra Zero. So I think that's kind of like the easiest way to incorporate Algebra Zero into your existing curriculum, because a lot of teachers don't really have any good introductional material. So use this, and that's the easiest way. Another way is, you know, summer is coming. You know, think about it, summer coming. Well, because unfinished learning or learning loss, you know, whatever you call it, we all have to do something during the summer. But we all know a lot of kids, even maybe some teacher to a degree, you know, says, I just finished Algebra 1. So what should I do? I've been teaching it for 10 months. Now you ask me to recover everything in 2 weeks, repeat the same thing. So in that case, things you're looking for something new, use Algebra Zero. So that's another way to improve it. The third way is there's really no more change. You know, you keep doing whatever you've been doing. However, just tell the kids, says, hey, next week, we're going to introduce, let's say, system of linear equation. Here's a story. Here's a website. Go back and, you know, watch the story, you know, read the story on your own. It's very hard to get the kids motivated the very first time, but based on our experience, once they watch it once, a lot of kids want to go back. So that means, you know, there's really no additional work on your part except, you know, reminding them, here's a website, go back. Also, what we're trying to do is implement SSO, you know, when kids and teacher, you know, log into your existing, you know, management system, there's going to be an icon on the desktop. All they need to do is click on the icon. That should be it. So there's so many ways, you know, we can implement it without interrupting your existing plan, existing everything. So that's how I would recommend, until someday you feel like, you know, Mike, we should really work together and come out with a brand new curriculum for our district. Well, that's another story, maybe a couple of years down the road. But, you know, we're flexible. Our job is to make your life easier by providing those things. Now, one more task for you. I'm sorry, you know, Monica, you can say something.
It's okay. Would you be able to show the last slide so that they can get the email address? And there's such good questions. I want to make sure that we get to as many of them as possible. The videos are, I'd say, between 12 to 18 minutes. And as Mike stated, they're really a great way to introduce the concept. Someone had asked whether, what's the difference between these videos and the ones that come directly in your curriculum? This is story-based. So students will be able to recall what happened in the last episode, and therefore it just gets them all engaged in like, well, what's going to happen next? Because it is not just focusing on the math. It is actually a story, and it's this narrative that they're already hooked and they want to know what's going to take place in the upcoming episodes. So it's a way to just bring the students together. It builds and strengthens the class community. And through that, they're guaranteed to learn something that will stick with them for them to apply it. The recommendation in terms of like how long, well, there's 8 episodes in the algebra series, and I'd say each one is about 8 episodes. Is that safe to say for K through 2 and 3 through 5?
Yeah, you know, for algebra, you know, the story 8 episode, and actually we have an entire, you know, curriculum for even, you know, Algebra 0 to Algebra 1, you know, that basically, you know, if you only have a limited time, use this episode. If you have more time, talk to us. We have a lot more material.
Right. It's so much
I can't
more.
even present you today. Again, another thing is, you know, let's say, you know, for your 3rd grade, you know, 3rd through 5th or 3rd through 6th, you know, school. And if we implement it, you know, right after you get back, you know, I mean, like after Christmas, you know, New Year, then, you know, I mean, and, you know, the smarter balance testing is coming maybe in March or April. And you might think I exaggerate a little bit. I would say, you know, for some school, that are really serious about it, if we implement this thing, well, I think, you can see a big difference by the time, testing is here. Because for third grade, we have actually third grade, we have a 10 episode. We cover, the geometry shape and, the concept of, parameter area, that they only touch a little bit. Then, the, addition, subtraction up to like 1,000. Then the fraction, basically, you have to, actually the major component over there is the unit fraction. So unit fraction, then, so 10 episode covers all the major concept over there. Like I say, third grade, the reason I mentioned third grade is because 10 episode and basically literally 2 weeks or 3 weeks. If you gave us a month, we use a story, kids actually can really improve their conceptual understanding, followed by the practice, and that'll make the practice a lot more effective. So for third grade, I think literally a couple months, 2-3 months, you can see a difference. Fourth grade, a lot of time, to be honest, you have to go back to the third grade. Even some of the kids who can answer the third grade material without any problem, but do they really understand what you mean by unit fraction? So it's better to start from the third grade, then build up to the fourth grade. That's why the fifth grade, the higher grade, they are as it takes a little more time. That's why even though we have a material to cover the entire basic K through 10, I would recommend all the kids should read the story on their own. But to really make a difference, let's work on the third and fourth grade for the elementary school level. Literally 2 months. If we're serious about it, we can see a big difference.
We have 2 minutes left, and I want to make
I'm
sure
sorry.
that we address a couple things about the current languages that it's offered in and ones that they can expect to come, as well as the connection between Clever, if student logins would be something that Algebra Zero and Nevada are going to incorporate.
Yeah, we cut the also another thing, I'm sorry, Mike. Is there any way we can save the chat, because I didn't have a time to
We can save it by just you can press the 3 dots and then select
okay.
save chat.
I want to make sure we save that, because the question we never had a
If we could just say, for anyone that is eager to make use of this before their school fully adopts it, do email
email me info
Yeah.
at algebrazero.com. We have actually a group of people monitoring that email. We'll get back to you right away.
All transcript and recording will be posted in the future.
Okay, great.
Yes, all of this transcript in the chat and transcript of the presentation will be incorporated to your Canvas hub. So
Okay, great.
just watch for it in the future.
Thank you.
Is there a survey to complete? You gave us the attendance. Is there a survey?
I think that was the survey link that Mike placed in the chat.
What, just the attendance?
It's a Google
Oh, there it is.
form.
There it is. There we go.
So I
Alright,
put a
appreciate
bunch
that
of
survey.
I put a bunch of links. One is for the attendance, one is for survey, and one is for the link for the closing. We have a 15 minutes for the closing, and there would be a raffle on the closing if you want to win the prize. I believe there are big prizes on the very end. So log on to that session, closing session, and for you guys to win big prizes.
Thank you all so much.
So I'd like to thank I would like this opportunity to thank Mike and Monica for sharing with us Algebra Zero. If there are questions, you can email Janie Maloney and the team, and we will connect you with the presenters, and all your questions will be answered in a later date.
Yeah.
So the second
thank you all for coming.
you will be able to answer those questions.
Oh, I'm excited for you, Jennifer. I'm hoping that you'll be able to use it and enjoy it. So we're looking forward to everyone using it widespread. Thank you all so much, and thank you, Mike. Well, both Mikes.
Thank you, Monica.
Take care, everyone.
Thanks for coming and see you at the closing.
Thank you, Mike. Really appreciate everything.
Yeah, same here. Appreciate your presentation. We enjoy it.